Hey there, welcome to a video that discusses test, number 6 from last year, from spring 2015. Basically the chapter 14 test from last year for spring 2015. So I'm going to work out these problems, which are pretty close to the problems we had on our test today. And pretty close to the problems we've been doing the last few weeks. But as I mentioned in our email, that we had a lot of disruption this last few weeks, so I could see why this has been hard to learn the material when we haven't had consistency. So my hope is that when you watch this video, you get a better feel for this material, then we'll review it in class, and then we'll retest on Thursday. So starting with this one, sine of negative pi over 12, I'm going to utilize this formula, which was given to you. And if you hear yelling, that's people yelling about the fitness fair. I don't know what they're yelling about, maybe doing pull-ups. Anyway, so here's our formula. So you got to figure out what x and y are. Now, if I subtract 4 pi over 12 with 3 pi over 12, actually, let's do the other way around. 3 pi over 12 with 4 pi over 12, that would be getting us negative pi over 12, right? And 3 pi over 12, of course, is pi over 4. And 4 pi over 12 is pi over 3. So I'm doing sine of pi over 4 minus pi over 3. And I just plug it into the other side. So remember, x and y are my angles, right? X, y are angles. And our angles are pi over 4 and pi over 3. And then you just use unit circle knowledge, and you'll have the answer. Should be pretty straightforward. So if I work this out, sine pi over 4 is root 2 over 2. Cosine pi over 3, I believe, is 1/2. Cosine pi over 4 is root 2 over 2. Sine pi over 3 is also, what is that going to be? Root 3 over 2. There we go. So you should get root 2 over 4 minus root 6 over 4. By the way, you could also check this in your calculator. Make sure you're doing it right. So here's the calculator app. Clear, mode, radian, sine of negative pi divided by 12. And if I do root 2 divided by 4 minus root 6 divided by 4, they're the same. So I feel comfortable with my answer. So that's what you should do when you're checking your work. Moving right along, tan 255 degrees. So how am I going to combine this stuff? I could probably do 135 plus 120 degrees. So I'm going to do tan of x plus y, which of course is tan x plus tan y, or 1 minus tan x times tan y. Again, the formula is given to you. And again, we're doing tan of 135 degrees plus 120 degrees. Tan of 135 degrees plus tan of 120 degrees over 1 minus tan of 135 degrees times tan of 120 degrees. And if I keep going, let's see here. Tan 135 should be negative 1. Tan 120, I believe, is 1 over root 3, or root 3. It's actually a negative value. Yeah. Oh, wait one sec. I lied. It's negative root 3. My bad. And then 1 minus parentheses negative 1 times negative root 3. So it's negative 1 minus root 3 over 1 minus root 3. Because the two negatives make it a positive, but then you have a subtraction there. Now we check. So go back to the calculator app. So tan of 255, switch our mode to degrees. Remember, this wasn't a calculator portion, so you're able to do this to check your work. Nice, okay. And then, let's see, negative 1 minus root 3, and of course we've got to divide that by 1 minus root 3. Okay, that's acting a little weird. There we go. Okay. And notice that, I'm explaining and talking about this, but I'm still doing it pretty quickly. So the hope is that you guys can do this quickly as well. Okay. So let's move on to an equation. You have tan cubed theta minus 3 tan theta. So let's move everything over to one side. Just like you would solving any equation, right? Like if you had like x cubed equals 3x, I hope you would know to move everything over to one side. And then factor, because when you have factors, anything times 0 is 0, so you can set each factor equal to 0. See, what if I factor out tan theta? Tan squared theta minus 3. Set each factor equal to 0. This occurs at 0 and pi. So we're going from 0 to 2 pi. Tan squared theta equals 3. Tan theta equals plus or minus root 3. That's going to occur when theta is at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Number 2, I gave the hint to convert anything that's not sine or cosine into sine or cosine. So that's going to be a cosine over sine theta. And you guys should remember busting fractions. So let's bust the fractions. Multiply everything by sine theta. Even though I gave you guys that hint, some of you guys got stuck in first year and didn't bust the fractions. It might have been a while since we covered that material. And again, we haven't been meeting too often, so you probably just forgot. But by doing that, you make life so much easier for yourself, right? Because notice that sine theta times sine theta is sine sine theta times that fraction, sine thetas go away. 2 sine theta, that's 1. Cosine squared plus sine squared is 1. Sine theta is 1/2. And where's sine 1/2? That's going to be 1/2 at, let me think, pi over 6 and 5 pi over 6. And it looks like Will Horvath is walking into the classroom saying hello while I'm making a video. Go Washington Redskins. Woo! All right, let's talk about verifying an identity. Now in this case, you want to just work on one side, as I mentioned. What I probably would do is I would find the LCD for the left side, which of course is cos x times 1 plus sine x. So we're going to multiply top and bottom this by 1 plus sine x. And multiply this by cos x. So you have 1 plus sine x times 1 plus sine x. And then plus cosine squared x over 1 plus sine x times cos x equals the other side. FOIL, 1 plus 2 sine x plus sine squared x plus cosine squared x. Leave the bottom intact. And then hopefully you can see that that just equals 1. So you have 2 plus 2 sine x over factor out of 2 those cancel. 2 cos x equals this, and of course anything over cos x makes it a secant x, and you have it verified. I'm going to jump to number 5. We'll come back and look at 4 in a little bit, but a lot of you guys are stuck on this, and I was really puzzled. You know that's the third quadrant, okay? And you know tangent is opposite over adjacent. So opposite, adjacent, but make them negative because you're pointing down and left. Remember, down, negative, left, negative, up, positive, right? Positive. You guys have been doing this for many years. You should not make a mistake here. Pythagorean Theorem. You guys should know Pythagorean Theorem. That's 5. Sine 2x. I give you the formula. Sorry if I'm sounding a little hostile here, but I was just a little bit frustrated you guys missed this. Okay, what's sine x? Negative 4 over 5. What's cos x? Negative 3 over 5. Boom, get it done in 10 seconds. You shouldn't be spinning your wheels on this problem. Also, 4/5 is not x. X is an angle. X is an angle. Sine x is a ratio. Please, please, please do not confuse this. This is from day 1. We've been talking about this in chapter 13. So, 24/25, that's sine 2x. Tan 2y. That's 2 tan y over 1 minus tan squared y. Okay, you have the formula. Okay, let's look at y. That's in the 4th quadrant. Okay. And negative 12 over 13. Oh, we're going down. Better be negative. Hypotenuse. 13. Pythagorean Theorem. 5. Okay. Tangent is super easy. What's tangent at angle? 5 over negative 12. 2 times 5 over negative 12. That's why I put this first. I thought this was an easy problem for you guys. So that's 5 over negative 6. 1 minus 25 over 144. And personally, leave your answer like that. I didn't ask you to simplify it. So you guys need to be more like an attorney when you do these problems. If I don't say to simplify, why simplify? You're done. 5 over negative 6 is 1 minus 25 over 144. I don't care what else you do with the problem. Okay, last one. Cosine. X minus y. That's going to be cosine x times cosine y plus sine x times sine y. Okay. Well, I know cosine x, this is x over here, is negative 3/5. Cosine y is going to be 5/13. Sine x is negative 4/5. Sine y is negative 12/13. So you get negative 15 over 65 plus negative 48 over 65. You should get negative 63 over 65. So again, that's all that happens there. Okay, lastly, this problem. What happens here is that we're trying to write this as a sine and cosine function. So we should see that the midline is about negative 2. So k is negative 2. The period from top to bottom, so half the period is pi. So 2 pi over b equals pi, b equals 2. And then amplitude is going to be 4. No, it's going to be 5 because we're going from negative 2 to 3 or negative 2 to negative 7. And lastly, if we do it as a cosine, so you're going to have 5 times cosine, b is 2, x plus pi over 4, and then minus 2. Or y equals 5 times sine, if you want to start the sine over back there somewhere, 2x, and I believe that's going to be 3 pi over 4. I'll have to explain that in class tomorrow because the bell just rang and I have to clear out of here. So anyway, here's a video, about 15 minutes. I know I went through it kind of quickly. You could pause, rewind, try to make sense of it. We're going to do a lot of problems like this in class tomorrow, especially these problems here. These are super easy problems. Tan x equals 4/3, sine y equals negative 12/13. We did it recently. There's no excuse why you guys can't get this. I know you guys can do it. So we're going to work on it tomorrow, retest Thursday, then move on. All right, have a great day.